Hello again. I hope this time it will be a little bit longer talk than before the coffee break. So once again, yes, we are talking here about IPv6. Well, since the inception of NLNOG, the IPv6 was the topic, and it's unfortunately still the topic. It's not something we would do every day. We are still transitioning to it. The transition seems to be endless, because we are slowly deploying IPv6, but IPv4 is still the protocol of the internet, which is okay, except that there are not enough IPv4 addresses. I think we all know it here. And there are still some attempts to repurpose, 240/4, 127/8, or 0/8, all those talks, and all those articles about these things that actually get lots of hearts on RIPE Labs, which is the blog of RIPE and CC. Much more hearts than articles about IPv6, by the way. So people will still think that probably repurposing 240/4 will help us. I'm not sure. It will just delay the problem a little bit. And we have transition mechanisms that are helping us running somehow IPv4 and IPv6 at the same time. There are many of them, but there are two worth mentioning regarding access networks because they are special somehow. The first one is dual stack, and it's something that people don't really consider a transition mechanism, but it indeed is transition mechanism, which basically means that you are running IPv4 as usual, and you are running IPv6 next to it, and you are hoping that somehow the traffic will migrate to the IPv6 so you can turn off IPv4, but spoiler alert, it will not happen itself. The second one, which is a little bit more advanced, is called Net64, and out of all of other transition mechanisms, this one is the only one that allows unmodified end-user devices, sort of unmodified in theory, to access IPv4 resources. So it can allow network to be v6 only. We have this slide in our training courses that we talk about dual stack as the best transition mechanism. It's always the perception, because basically you have this IPv4 only that you always had, and you just add IPv6 on top of it. And so what can possibly go wrong? Everything will go well with IPv4. If there are any problems about IPv6, the web browsers introduce this little bit controversial algorithm called happy eyeballs that will try to switch fast to v4 if they think that v6 is not performing well. The biggest issue here is that it does not address the IPv4 address scarcity at all, because you just have IPv4 just like you had before. So by deploying IPv6, you are not solving this fundamental problem that there are not enough IPv4 addresses. Then there is this Net64, which allows us to deploy IPv6 only access networks, and at the same time have these networks sort of work, because not only native IPv6 word is accessible to them, but via this Net64 device, IPv4 internet is also available. In a similar way, Net44 makes IPv4 word available to private IPv4 networks. So it's not 100% accessibility, but it's good enough for today's internet services. In order to work, you also need DNS64, which is a nasty trick with DNS, which will make your devices think that everything is available over v6, because it will synthesize IPv6 addresses in the DNS answers in case the original resource only provides v4. It works very well. It's not a new technology. It has been around at least for like 10 years now. At RIPE meetings, such network is available since RIPE 67, which was in 2013. And at FOSDEM, it's the default meeting network, for instance. It works very well, but there is this but sometimes, and you run into some things that don't work because they cannot work easily, and that is first, IPv4 literals. If you don't use DNS, then DNS64 cannot work, and then IPv4 literals has no way where to connect. Then there is this legacy software that is using IPv4-only software because somebody who programmed it learned programming network sockets in 1994 and didn't change their approach ever since. And then there is this also dual stack services which claim to be dual stack in DNS, but in the end the v6 is broken and it's masked on normal network because we have these happy eyeballs. So. But then again, there are already Net64 networks deployed very widely and mostly in mobile networks and mobile carriers because they somehow choose to use this kind of network deployments. And they have also quite nice forces to mobile phone vendors or also all equipments that have SIM cards in them, basically, to make them work it. So they were forcing all major mobile phone vendors to make them deal well with Net64 networks. And what those mobile vendors did is quite different in Android and in iOS. In iOS, it's much more interesting, I would say, because Apple didn't want to do any workarounds inside their devices, and instead they just say, well, we have full control over our Apple Store, so we can just force our app developers to fix their apps. And that's what they do. Since 1st June of 2016, they don't allow any app that would not work properly on Net64. They are automatically testing it. So every developer in 2016, it was like big problem for all the iOS developers that they had to learn how the Net64 networks work and how can they test it, so what should they fix. But then again, even on iPhone, you have web browser, and with web browser, you still have option to put in their literal IPv4 address, and it should work somehow. So for that case, they developed this algorithm called Happy Eyeballs 2.0, which is like the Happy Eyeballs, but it also adds the thing that if you put IPv4 address literal in, it will somehow magically transforms it into Net64 prefix plus this IPv4 address, so it works somehow. Yeah, but then there is another case, and that you have your mobile that is IPv6 only works very well, but you then turn on this mobile hotspot thing and connect your computer to it, and you expect the computer to work as well. And for that reason, actually, I think that's capitulation from Apple because they just put their CLAT, which is the translation engine that basically translates IPv4 into IPv6 just in order to be translated to IPv4 back in the Net64. So it's some kind of like double translation, which, of course, as you hear it, you can basically find out that there are lots of corner cases where it goes wrong. But in general, it works good enough. So they use CLAT as well. They use it for tethering to a computer. Whereas Android got this easy approach and said, well, let's put that CLAT, and this will fix all the previous issues Windows have to deal with, forcing app developers to fix their apps or doing like Happy Eyeballs 2.0 or those things. So basically for both Apple and Android smartphones, IPv6 only is very doable and working. For desktops, it's a little bit harder. First of all, Happy Eyeballs 2.0 is only in Apple. And in Apple, it's only in those apps that are using the high-level APIs like Safari, but not in those apps that are ported from other OSs like Chrome. So if you use Chrome and you are v6 only and you put the other IPv4 literal, it will not work. It will work only in Safari. In Windows, Linux, or Chrome OS, there is no CLAT at all, so you will still have this. I'm not saying that it will not work. It will still work very well, but there will be this but sometimes things which will not work. Very famous is Spotify desktop app that doesn't work over Net64, which I actually tested last week and it worked, so, but let's not spoil the story with facts. It didn't work for years. Then IPv4 literals, as I said, dual stack servers with broken v6. Yeah, and we have this Happy Eyeballs, this legacy Happy Eyeballs algorithm that is only trying to switch to v4 if v6 seems to go wrong. But then again, if you don't have v4, there's nothing to switch to, so it doesn't really help. Yeah, and then there is this VPNs, and most corporate VPNs are set up in v4 only, and it's usually just a configuration issue, but if you connect to v6 only network, it will just not work at all. So, can we do something about it? Because if we just keep using dual stack, the requirements for v4 addresses will grow because the number of devices that people bring to networks is growing all the time. And even those more devices are like mobile phones that can do very well IPv6 only. We cannot easily distinguish them from the devices that would need v4 address to work properly. So, is there any way how to do it? And of course, that's why I have this talk. The answer is yes. There is this new RFC, which standardized DHCP option 108. It's DHCP v4 option, and the DHCP v4 option is called IPv6 only preferred. How exactly does it work? If you connect your device, like your mobile phone, into a network, the device will start looking for v6, of course, by sending route to solicitation, and also start looking for v4 connectivity by sending out DHCP discover. And in the DHCP discover, the device actually announces that it's discovering not only its IP address and all the thing, but also is discovering for option 108. And if the DHCP server gets this discovery request asking for option 108, and the DHCP server is configured in a way that it's aware that the network is v6 only capable, then the server will respond with offer of IPv4 address, but at the same time in the offer there will be this option 108 offered to the device. And once the device gets this offered option 108, it will think like, okay, so this network doesn't really need IPv4, so I will just stop here. The device will stop there, don't finish the DHCP transaction, and continue working on v6 only. So this way, IPv6 only capable devices like mobile phones can opt out from v4, whereas the network still supports v4 for legacy devices that don't ask for option 108. So those devices will still get their IPv4 address like normal. And therefore, you can have one network that has both dual stack clients and v6 only clients. And people don't have to select different SSIDs because if you ask people to do something, it's not going to work well. And also you have this opportunity that your DHCP pool will not grow in time because the number of devices that will need IPv4 will go probably down in time, not up. So this is what is called IPv6 mostly network that supports both v6 only and dual stack at the same time in one network. The question is this already deployed? And for my surprise, I did run a measurement during RIPE 84 in Berlin this year, and I found out that 2/3 of devices actually support it. They were actually requesting option 108 in their DHCP discover messages. Basically, it's all new Androids, all new iPhones, and quite a surprise, also macOS devices. So from the device point of view, it's already ready. If you deploy IPv6 mostly network, you will save up to 66% of your IPv4 address pool for that network. Of course, this macOS thing, that is something that rings a bell because macOS is a little bit special in a way that it's still a platform that allows you a lot of freedom in a way that you can run very old legacy software that could be IPv4 only, and nobody will stop you from doing it. There's no it's not compulsory to use some app store. So how does this not break? Well, it turned out that in the newest macOS there is also CLAT inside, but it's very well hidden. And it only turns on by 2 factors. First thing is that DHCP option 108, I just talked about it. But the second thing you also need is that the NAT64 prefix has to be shared using array option that is called pref64. So, because the device, of course, in order to set up the CLAT, it has to know what the NAT64 prefix is used. And this pref64 is a way how you can carry that information as an option in router advertisement. So it's a little bit more secure than the previous version of Discovery that uses DNS64 using a special domain name IPv4 only.arpa. In a way that if somebody screws with your router advertisement, you have much bigger problems than just wrong configured CLATs. So it's not secured in a way that will be encrypted or authenticated, but secured that it's just sharing fate with other configuration parameters. Yeah, so in order to have your network IPv6 mostly, you need all these things together. So basically the network has to have NAT64, pref64, DNS64, and IPv4. Maybe, and if I play with this, you get this idea that maybe if you have NAT64 and pref64, you don't already need DNS64 because it should be sufficient. In theory, it is like it, but in practice, you need DNS64 for Safari and for iOS because those high-level apps on Apple devices will actually stop using IPv4 at all if they find out that the network is v6 only. So that means if there is this DHCP option 108, they will just stop using v4, and unless you have DNS64, the IPv4 will be invisible for them because they will not try to use NAT64 without DNS64. On iOS, well, I personally don't have an iPhone, but I heard from people that tried it that basically the CLAT is there, but it's used only for voice over Wi-Fi, so something like low-level system thing, but not any app that you use on the phone itself. And in this network, you also need IPv4, of course, because that's how the legacy devices will work. Now, that's basically the main point I was going to talk about here. Now, a few of my experience of running IPv6 mostly network from my own perspective. First of all, you need the DHCP option 108. This is very easy. First of all, there's native support in Kia. So if you use Kia as a DHCP server, it's just configuration. But the nice thing is that there is no special requirement for special processing on the server side. So virtually any DHCP server that supports custom options can be set up to provide the option 108. There's just option 108 with 4 bytes of one number that is telling the client how long the IPv4 stack should be deactivated. So you just put there like half an hour. And that's it. The only thing that is a little bit surprising is that you need to have some pool of IPv4 addresses, because if the IPv4 address pool is full, then the server will not respond, even if in the end there is no need for any address to be assigned. So there still need to be some addresses in the pool. With pref64, which is the option of router advertisement that will share the NAT64 prefix, it's much harder because in general, routers don't allow custom array options in their configuration, so you need to have your firmware of your router upgraded to support this option. And that's like really stupid because we already had this problem with recursive DNS server option, which was standardized much later than the array. And we have this problem again, and we'll probably have this problem again and again and again. So the only thing that you can now use is if you use some software routers. There are patches. There is patch for RIDVD, there is patch for FRR, and there is patch for ODHCPD, which is used in OpenWRT. Most of them are not merged, so they are merged or not released, so you have to compile the bleeding edge software. And the last thing is, yeah, I gave it a try, and I found some interesting surprises on macOS, which I would like to share. I also reported them to Apple somehow, and I got confirmation that they are tracking them internally. So hopefully before these networks are really deployed, this will be fixed. First of all, if the CLAT is set up, which is in this gray area, it just chooses completely randomly a IPv6 address that is used as the outside address of the CLAT. It will use ULA address if you have it in network. It will use even deprecated prefix if you are announcing 2 prefixes for, let's say, quick switching between 2 prefixes. It will just use whatever is there, and it does completely random choice, which is probably not good. But it's not causing big harm if your network is very simple. The second thing is that if you have your configured custom DNS server using IPv4 address literal, somehow the operating system resolver is not able to use the CLAT engine inside, but the utilities like host or dig will use them. So here you have example that I have 4 ones as an name server. I can use command host to resolve google.com, but if I try to ping it, it will just tell me unknown host because after timeout, because it just cannot reach IPv4 literal DNS server. So that's a little bit hiccup that can be easily solved by turning off custom DNS resolvers or setting them up for v6 address. And the last and I think the most serious thing is that somehow, I don't know the reason, whenever the CLAT is active in macOS, it will influence the ordering of the getOtherInfo system call library, which is the library call that is used for resolving domain names into IP addresses. And the order is actually the order the thing that is trying to connect should use to try first and second. And somehow, IPv4, even though it's going through the CLAT, is preferred over IPv6 in dual-stack servers. So if you are connecting to dual-stack server with some app that is using getOtherInfo, which is basically every app except for web browsers, it will prefer going through CLAT and NAT64 than going natively via v6. So this may have a bigger impact on the stress of NAT64, and I really hope that this is something that is going to be fixed soon. Yeah, that's basically it. I hope it was not too overloading. I have some pros and some cons at the end, so I can just, you can already see what the pros are, that basically you have only one network, and you don't waste IP4 addresses for devices that don't need them. And even the dual-stack clients, the legacy devices, still use the minimum of the IPv4 because there's still DNS6.4 in the network. So all the apps that are capable of v6 will go via DNS6.4 and NAT6.4, then going directly over native v4. The problem is that the most complex network you can set up, basically, because it's dual-stack plus IPv6 only, both in the same time. You still have to deploy IPv4 there, so yeah, you don't have immediate saving on IPv4. And you still need NAT. In this case, NAT6.4, but if you're already using NAT4v4, then replacing NAT4.4 with NAT6.4 is not a big improvement, I would say, if ever. And then, of course, there are some baby issues, like if you have such network and you connect your Chromecast, which is running on dual-stack, with your Android phone that is running on v6 only, they can just not communicate with each other. They just say it's impossible to connect. And that's it from me, and I would be happy if you have any questions. If you can come to the microphone.
I think there are questions on IRC, and if you have one when you're here in person, then please go to the microphone and state your name and ask your question.
I have a question here via IRC from Tijn. He's asking, what is the status of the support of the DHCP option on other operating systems like Windows and Linux?
Windows doesn't support it yet, as far as I know. Linux offers you freedom. So, for instance, in DHCP, my favorite DHCP client is called DHCP CD, and it supports it. But of course, you just configure it to support it. It will support it, but it will not do any other magic like setting up a CLAT, or you have to do it yourself.
Thank you.
Hey, just want to thank you for the presentation. I'm really surprised to see that macOS now has a CLAT, and I think that's great news. And yeah, if they can fix the outstanding bugs, that would be really useful for the future. So thanks.
Thank you.
Hi, I was just wondering, what's stopping anybody from injecting DHCP option 108 packets or messages to clients if they are just going to shut down IPv4?
Nothing.
Wouldn't that be a vulnerability then?
Well, if you are able to inject DHCP replies in any network that is running v4, you will break it. And just injecting 108 is one of the myriad of options how to break it. Basically, securing network against rogue DHCP servers is a very basic thing how you secure access networks. So I don't feel there is any new attack vector in this.
Okay, so it's an acceptable risk. Okay, could be interesting to troubleshoot actually.
Definitely.
Hi, so earlier it was mentioned that Windows and Linux don't yet support the 108 option and or setting up a CLAT. Is there any future outlook that maybe they will in the future? Or
That's a really good question, but not for me. I have no idea.
That's unfortunate. Thank you.
We have to ask Microsoft, we have to ask others. Yeah.
Thank you.
I talked to Jen Linkova from Google, who's very excited about this, and she was telling me something that Chrome OS should have supported it at some point in time.
Okay. We have time for one more from Arjen.
I was wondering, what is the idea behind the time that you switch off the IPv4 stack?
You mean the time and the option on 108, how long it should be
You
suppressed?
have to give a time, and it switches off the IPv4 stack during that time. For that time. I have no idea why, and also, what happens after that time? I know it switches on again.
Well, my guess is it sort of follows the way how DHCP works in general, that you get least addressed for a time, and after a time you have to go ask again whether you still can use it or whether you can release it, and this is the same thing. So basically, you are asking not for address but for configuration, and you get information that you should stop asking for address for half an hour, and after half an hour you come back and ask, is there now IPv4 address for me? And they will just say no, still not. Okay, so I'm not really sure whether it's useful in any way, but yeah, that's how
so it follows the paradigm of DH.
Yeah, it seems like this is like permanent thing. It's not like the network would switch from this setup to a different setup within minutes. Okay.
Thank you, Ondr. We have a small present for you.
Oh yeah, just one more thing. I have just before I end, I have just this small thing that my colleagues were asked. We have this running this survey. Oh, you don't see it anymore. The survey about NLNOG participation. So since this is NLNOG, we would really like to
Please
you to participate.
scan the code now.
Scan the code now. Yeah.
Fill it out.
Thank you very much.